So, good morning children. Let us continue. So, we have seen that elements are arranged in the periodic table based on their configuration, and each of the period will accommodate certain fixed number of elements. That is based upon how many electrons can be accommodated in the particular subshell. If I take up this first period has only 2 electrons. The reason, two elements. The reason is S can accommodate only 2 electrons. So the maximum capacity of first period is how many elements? 2. Coming to second and third, which will have S and P block, a total of 8 electrons can be accommodated. Hence, a total of 8 elements are accommodated in each of this period. Similarly, coming to fourth and fifth period, they are going to accommodate 18 elements. Why? Because D block is added, which can accommodate another 10 more. Followed. Then sixth, you all have learnt the longest, which will contain 32, because F block is also included in that particular period. Fine children. So now let us see how what are these elements in this periodic table are termed as. Now we all know the modern periodic table has 8 groups. Now the first group is also called as, now this is known as 1A or first group, which is called as Alkali Group. Okay, what is it termed as? Alkali Group. Now, why they are called as alkali group? Now, you all know what are alkalis. The bases which will dissolve in water are termed as alkalis. So, if you see the first group elements from lithium, they all dissolve in water. So, the bases formed by lithium, that is lithium hydroxide, sodium hydroxide, potassium hydroxide, they dissolve in water. So, that's why these are called as alkali group. Now, if we see the configuration, children, S1, the configuration is what, children? Valence configuration is S1. Hence, the same S1 is the common valence configuration for the elements of all the first group elements. It begins with hydrogen and ends with water, francium. So, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So, these are called as alkali group metals. Then coming to the second group. Now this second A group is called as alkali earth metals or alkaline earth metals. Now what is the difference between the alkali and alkaline earth metals? There is not much difference. Major differences with respect to their density and the valency. Now we all know the outer valence configuration is S1. That means it has a capacity to donate 1 electron. So what is the valency? Common valency? A valency is how much? Plus 1. Here how much valency? Plus 2. So they can give 2 electrons, donate 2 electrons, and these can donate 1 electron. And these are more denser when compared to the first group elements. Otherwise, both are what, children? Metals. And why they are metals? They have a tendency to give electron. That is one of the criteria. And another criteria is these are all solid in nature. Most of these are these solids in nature. Now coming to the third group. Now this third group can be referred as the boron family. Okay. So third group. Third A, or it can also be termed as 13th group. We can also call it as what, children? 13th group. Then similarly comes what? The carbon family, which is termed as 14th group or 4th A group. Then 15th group, that is nothing but the nitrogen family, which is termed as 5th A group. Then oxygen family, which is 6th A group or 16th group. Then this group, okay, this is that is from fluorine, chlorine, bromine, iodine, up till iodine, children. That is 7th group is termed as halogens. What are they called as? Halogen. What is meant by halogen? Halo means salt, gen means to form. Now observe, we all know when sodium combines with chlorine, they form sodium chloride. Similarly, potassium combines with chlorine to form potassium chloride. What are all these? These are nothing but salt. So, the 7th group elements will combine with the first and the second group elements to form salts. That is why these are called as what, children? Halogens. What are they? Halogens. Then, coming to the last group, which is also termed as 8th group or 18th group or inert group. Why these are called as inert group? Because they are the least reactive elements. And why they are least reactive? As they have the completely filled orbit, filled shell. Hence they don't want to either share the electron or accept the electron. So hence they are not going to undergo any chemical reaction, hence called as inert group or noble group. So what would be their valence configuration? S2P6. That means their valency is 0. How much is their valency? 0. Come to the 7th group, their valence configuration is S2P5. That means they require one more electron to become stable. So that's why their valency is -1. Similarly, 6th, their valency is -2. Then come over here, nitrogen, it is going to be -3. Carbon, it is going to be 4. Then boron is +3. Then if I come to this one, it is +2 and +1. Now observe, children, what has happened to the valency. On to the left side, the valency is of positive, and gradually when we come to the right side, it will reach the maximum of 4, then decrease and then become negative, electronegative, and reach a valency of 0. Starts gradually increasing, positive to gradually to negative, and finally becomes 0. Clear, children? So we have 4 major families here. Actually all the groups are the families, but what you need to learn right now is the alkali group, the alkaline earth metal group, the halogen group, and the noble group. And the oxygen family is of 6th, nitrogen family is of 5th, carbon family is of 6th. Now, in the previous chapter, you all have learned that all the elements are divided basically into 2 categories, metals and non-metals. And you also have a third category which is called as metalloid. So the complete periodic table is also has accommodated all the metals onto one side or onto the left side. Those are called as metals by nature. So what, up till where the metals are lying? Up till your third group. Am I clear, children? So till third group, all these are, or the 13th group, these are all metals. That even includes D group, children. But the first and the second group are called as lighter metals or light metals, and the D block up till the 13th block are called 13th group, they are called as heavy metals because their density is very high. They are very high, strong, hard, solid metals. Then come to the right side. As the valency changes from positive to negative, the elements also become non-metals. So the metallic nature decreases, and these are termed as what, children? Non-metals. But then there is an exception. Between the metals to the non-metals, a transition phase wherein the metals are like changing to non-metals. Before that, there are some there are some elements which will show the characteristics of both metals and non-metals. Hence, these are called as what, children? Metalloids. What are these called as? Metalloids. What are metalloids? Metalloids are which have the properties, some properties of metals, behave like both metals and non-metals. That's why these are also called as semiconductors. And these semiconductors are widely used in designing your computer chips. So what are the examples of these metalloids? There are only 8 metalloids. The first begins with boron, then come to silicon, germanium and arsenic. Then antimony, which is the stibbium, it is also known as stibbium, symbol is Sd. Then tellurium, polonium and astatine. That is why astatine is not referred as halogen. Though it is a 7th A group element, but it is not a halogen because it is more or less like a metalloid. Clear, children? So these are the red ones are called as what, children? Metalloids. So now you see the periodic table has very conveniently accommodated the metals, the metalloids and the non-metals in the periodic table. The left side will have the metals and the right sides, extreme right, will have non-metals, and between them lie the metalloids. So hope, children, you will revise this, and further we will continue in our next session.